Here is about the electrochemical principle of metallurgy. So electrochemical reaction is one of the major things through which you are able to extract the metals. Using anode and cathode with an electrolyte in it, and there is a bridge between it. So here is a sample process of how the electrochemical reactions are happening. You are able to see through the electrochemical reaction the electricity is generated. Here is the agenda. We are going to talk about the metallurgy of aluminium, the electrolytic reactions, copper from low grade ores and scraps. These areas we are going to look into. This is one major area I am looking into, the metallurgy of aluminium and copper from low grade ores and scraps. So, electrochemical principle of metallurgy. We have seen many things. So, we have seen how principles of thermodynamics are applied to pyrometallurgy. Similar principles are effective in the reduction of metal ions in solution or molten state. Hence, they are reduced by electrolysis or by adding some reducing agent. So, in the reduction of a molten metal state, the electrolysis is done. Such methods are based on electrochemical principles which could be understood through the equation here. So, N is the number of electrons and E theta is the electrode potential of the redox couple formed in the system. You are able to see, due to electrolysis, you are able to see the metal, it's started moving as electrons and it's getting deposited here. So electrons consuming is happening, that's called reduction, and electrons producing is happening, this is called oxidation. The both is called as a redox couple. More reactive metals have large negative values of the electrode potentials. So the reduction is difficult. If the difference of two E theta values correspond to a positive E theta and consequently negative delta G theta in the equation of this one. E theta is positive, obviously delta G theta is negative. Then the less reactive metal will come out of the solution and the more reactive metal will go to the solution. So this is a typical example. You got your copper 2 plus with iron, you got copper and Fe2 plus separately. In simple electrolysis, the Mn plus ion are discharged at negative electrodes and deposited there. This is a typical example of how your anode and cathode is working. So precautions are taken considering the reactivity of the metal produced and suitable materials are used as electrodes. Sometimes the flux is added for making the molten mass more conducting.